ASNT Level 2. Magnetic Particles Testing. General Examination. Note down your answers in notebook and verify with my answers at the end of video. Magnetic particles testing is a non-destructive testing method used to detect surface and slightly subsurface discontinuities in ferromagnetic materials. It is an essential technique used in various industries such as aerospace, automotive, and manufacturing. The process involves applying magnetic particles to the surface of a material while it is magnetized. If there are any defects present, the magnetic particles will be attracted to them, indicating their location and size. The importance of magnetic particles testing cannot be overstated. It is a reliable and cost-effective way to ensure the safety and integrity of critical components in machines and structures. By detecting defects early on, potential catastrophic failures can be avoided, saving lives and preventing costly repairs. In this presentation, we will explore the different types of magnetic particles testing, the equipment needed, how to perform the testing, and how to interpret the results. Question point 1. Which of the following is not a property of magnetic lines of force? They form closed loops which do not cross. The density increases with distance from the poles of a permanent magnet. They are considered to have direction. They seek paths of least magnetic resistance or least reluctance. Question point 2. Surrounding an electromagnet, the magnetic field is strongest immediately after the current ceases to flow, while the magnetizing current ceases to flow at the time the magnetic particles are applied to the part, just prior to current reversal. Question point 3. The value of permeability is a fixed value depending upon the type of material. Between and 100 for all ferromagnetic materials. Between 0 and 10 for all ferromagnetic materials. Dependent upon the amount of magnetizing force necessary to overcome saturation. Question point 4. The flux density of the magnetism induced by a coil is affected by the coil size, the current in the coil, the number of turns in the coil. All of the above. Question point 5. How many turns of a coil will be needed to establish a longitudinal field in a steel shaft that is 22.86 cm long and 7.62 cm in diameter? 3000 amperes magnetizing current is available. It is desired to magnetize the part in accordance with the formula Ni equals 45,000, 1. 3, 5. 7. Question point 6. How many ampere turns are required to magnetize a part that is 40.6 cm long and 5 cm in diameter? 9000 ampere turns. 5625 ampere turns. 2812 ampere turns. None of the above. Question point 7. The lines of flux or force in a circularly magnetized ferromagnetic bar are aligned through the piece from the south to the north pole. Are aligned through the piece from the north to the south pole. Leave the south pole and enter the north pole. Are contained within and around the part. Question point 8. In which magnetizing method is the current passed directly through the part, thereby setting up a magnetic field at right angles to the current flow? Longitudinal magnetization, coil magnetization, central conductor magnetization, none of the above. Question point 9. Which of the following is false concerning a magnetic field in and around a hollow conductor as compared to that of a solid conductor of the same outside diameter when both are of the same magnetic material, and when the applied current is the same? The field immediately outside the outer surface of the hollow conductor is greater. The field gradient inside the hollow conductor is steeper. The fields outside the conductors are the same. The fields are the same at the center. Question point 10. The field in a section of ferromagnetic pipe being magnetized by means of a central conductor is strongest at the Ends of the pipe, outer surface of the pipe, inner surface of the pipe. The field is uniform at all places. Question point 11. For a 7.6 cm diameter bar, how much current is needed to magnetize the bar for the detection of longitudinal discontinuities? 5,500 amperes. 16,500 amperes. 1,000 amperes. 3,000 amperes. Question point 12. For detection of longitudinal discontinuities, a 7.6 cm diameter bar is magnetized in the longitudinal direction, the circular direction, the clockwise direction, none of the above directions. Question point 13. A bar that is 5 cm by 10 cm by 30.5 cm is being magnetized in the circular direction. About how many amperes are required using the perimeter approach? 2200, 4500, 3800, none of the above. Question point 14. An advantage of AC is that it is most readily available. Equipment can be made lighter. It leaves the part demagnetized. All of the above. Question point 15. When a magnetic field cuts across a crack, electrons begin jumping back and forth across the crack. The crack begins to heat up. Magnetic poles form at the edges of the crack. All of the above. Question point 16. A disadvantage of AC current is that it cannot be used with dry powder. Has poor penetrating power. Can only provide low flux densities. Cannot be used for residual magnetic particle testing. Question point 17. What causes a leakage field in a steel bar? A crack. Reversal of the magnetic field. Paint on the surface. All of the above. Question point 18. An indication is a defect under which of the following conditions? If it is greater than 3.8 centimeters long. If it exceeds the limits of a standard or specification. If it is deep. Under all of the above indications. Question point 19. Paint will not affect the detection of a crack if the paint is thick and the defect is subsurface. The paint is thin and the crack is parallel to the direction of flux lines. The crack is sharp and the paint is thin. All of the above. Question point 20. A magnetic particle indication is sharp and very fine. This suggests that the discontinuity is subsurface seam. A shallow, tight surface crack. Porosity. A deep crack. Question point 21. Among the following, the best type of current for the detection of fatigue cracks is half-wave direct current, alternating current, direct current, half-wave alternating current. Question point 22. Continuous magnetization provides the most sensitivity because the magnetic particles are present while the part is being magnetized. The magnetic field is greatest while the magnetizing current is on. All of the above. Neither of the above. Question point 23. The sensitivity of magnetic particle testing is greatest when the discontinuity is parallel to the direction of the magnetic flux lines. Perpendicular to the flow of the magnetizing current. Perpendicular to the direction of the magnetic flux. Perpendicular to the line between prods. Question point 24. To provide reliability and reproducibility in magnetic particle testing, written procedures should include location of the coil and current for each magnetization. Requirements for ammeter calibration. Type and concentration of the particles. All of the above. Question point 25. The magnetic particles are noticed to bunch in some fillet areas and stand on end on the edge of a part being magnetized. These observations indicate that the particle concentration is too low. Flux density is excessive. Flux density is too low. Magnetizing current should be changed from AC to DC. Question point 26. Flux density is a measure of the number of magnetic flux lines perpendicular to an area of cross-section. If a discontinuity is in the plane of the unit area, the strongest magnetic article indication will be formed when the discontinuity is inclined at 45 degrees to the flux lines, parallel to the flux lines, 90 degrees to the flux lines, 135 degrees to the flux lines. Question point 27. Prods are being used to magnetize a weld area. When dry powder is dusted on the surface, it is observed that there is no mobility of the particles. What is the most probable reason for this observation? The magnetizing current is not high enough. The flux density is too low. DC is being used. All of the above are possible reasons. Question point 28. The current from portable high amperage units can be applied to the object using prods, cable coils, pre-wrapped coils. All of the above. Question point 29. How can parts be tested to determine if they have been adequately demagnetized? By bringing a suspended paper clip near the middle of the part. By using a small horseshoe permanent magnet. By using a small magnetometer held at a corner of the part. By sprinkling some magnetic particles on the part. Question point 30. The statement, magnetic particle testing can be applied to plated and painted parts. May be true depending upon the thickness of the coating. May be true if flux densities are increased to compensate for the coating thickness. Is true only for circular circumstances. Both and. Question point 31. A group of indications, some sharp and some broad and fuzzy, were found on an area of a small forging. Demagnetization and reinspection eliminated these indications. What was the probable cause? Forging lap. Magnetic writing. Change in permeability. Subsurface variation. Question point 32. Magnetic particle testing is most likely to find subsurface discontinuities in soft steels with high permeability, soft steels with low permeability, hardened steels with low permeability, hardened steels with high permeability. Question point 33. Which of the following is not an advantage of magnetic particle testing? Fast and simple to perform. Can detect discontinuities filled with foreign material. Most reliable for finding surface cracks in all types of material. Works well through a thin coat of paint. Question point 34. Which of the following does not represent a limitation of magnetic particle testing? The type of materials which may be effectively tested. The directionality of the magnetic field. The need for demagnetization. The ability to detect discontinuities filled with foreign material. Question point 35. The most effective NDT method for locating surface cracks in ferromagnetic materials is ultrasonic testing, radiographic testing, magnetic particles testing, liquid penetrant testing. Question point 36. A discontinuity which is produced during solidification of the molten metal is called inherent. Processing. Service. None of the above. Question point 37. Pipe would be classified as what type of discontinuity? Inherent. Processing. Service. None of the above. Question point 38. A seam would be classified as what type of discontinuity? Inherent. Processing. Service. None of the above. Question point 39. A lamination in steel plate would be classified as what type of discontinuity? Inherent. Processing. Service. None of the above. Question point 40. an internal rupture caused by working steel at improper temperatures is called a lap. Cold shut. Forging burst. Slag inclusion. Question point 41. Cracks which are caused by alternating stresses above a critical level are called stress corrosion cracks. Cycling cracks. Critical cracks. Fatigue cracks. Question point 42. Cracks which are caused by a combination of tensile stress and corrosion are called stress corrosion cracks. Cycling cracks. Critical cracks. Fatigue cracks. Question point 43. Which of the following are ferromagnetic materials? Aluminium, iron, copper. Iron, copper, nickel. Copper, aluminium, silver. Iron, cobalt, nickel. Question point 44. The reverse magnetizing force necessary to remove a residual magnetic field from a test piece after it has been magnetically saturated is called hysteresis. Coercive force. Demagnetizing flux. Reverse saturation. Question point 45. Magnetic lines of force enter and leave a magnet at saturation. LD ratios of greater than 4:1. Flux concentration points. Poles. Question point 46. The ease with which a magnetic field can be established in a test piece is called reluctance. Retentivity. Permeability. Electromagnetism. Question point 47. Opposition to establishment of a magnetic field in a test piece is called reluctance. Retentivity. Permeability. Electromagnetism. Question point 48. The ability of a material to remain magnetic after the magnetizing force is removed is called reluctance. Retentivity. Permeability. Electromagnetism. Question point 49. A magnetic field which is contained completely within the test piece is called a confined field. Longitudinal field. Circular field. Saturated field. Question point 50. Which of the following produces a circular field? Coil. Head shot. Yoke. All of the above. Question 51. A technique used to find transverse discontinuities at the ends of longitudinally magnetized bars by the use of transient currents is called a coil technique. A fast break technique. A yoke technique. A head shot. Question 52. A leakage field is strongest and a discontinuity interrupts the magnetic flux lines at an angle of 0 degrees. 45 degrees. 90 degrees. 180 degrees. Question 53. The best method of inducing a circular field in a tube is by a central conductor. Head shot. Coil. Prod technique. Question 54. Magnetic flux density is 0 at the inside surface of a tube magnetized with a central conductor. The outside surface of a tube magnetized with a central conductor. The outside surface of a bar magnetized with a head shot. The center of a bar magnetized with a head shot. Question 55. Magnetic flux density is highest at the outside surface of a nonferromagnetic tube magnetized with a central conductor. The inside surface of a nonferromagnetic tube magnetized with a central conductor. The outside surface of a ferromagnetic tube magnetized with a central conductor. The inside surface of a ferromagnetic tube magnetized with a central conductor. Question 56. an important consideration when using a direct contact method is lifting power of the yoke. Coil diameter. Preventing arc burns. Field strength adjacent to the coil inside diameter. Question 57. A prod method would be most sensitive to cracks, parallel to a line connecting the prod contact points. Tangential to a radius from each prod contact point. Perpendicular to a line connecting the prod contact points. Perpendicular to the long axis of the coil. Question 58. When using prods, arc burns may be caused by which of the following? Dirty contact tips. Inadequate pressure. Too large a magnetic current. All of the above. Question 59. The most common source of DC current for magnetic particle testing is motor generators. Rectified AC, storage batteries. None of the above. Question 60. Fields generated in ferromagnetic material with AC current are useful for locating all discontinuities. Surface cracks. Subsurface discontinuities. Internal porosity. Question 61. A common rule of thumb to use for current required in circular magnetization, 1000 amps 25 mm of diameter. 1000 ampere turns 25 mm of diameter. 1000 amps 25 mm of prod spacing. None of the above. Question 62. The formula, Ni equals 45,000, is used to calculate the proper magnetizing current for prod magnetization. A head shot. A central conductor. Coil magnetization. Question 63. The formula, Ni equals 45,000, gives proper magnetizing current for a coil, regardless of coil size as long as the test piece is not larger than 1/10 the cross-sectional area of the coil. AC current only is used. The test piece essentially fills the coil. The test piece is held tightly against the coil. Question 64. For direct contact magnetizing methods, the magnetic field is oriented in what direction relative to the current direction? Parallel. At 45 degrees. At 90 degrees. At 180 degrees. Question 65. For direct contact magnetizing methods, current should be flowing in what direction relative to expected discontinuities? Parallel. At 45 degrees. At 90 degrees. At 180 degrees. Question 66. What is the magnetic field strength at the surface of a 100 mm diameter bar as compared to that at the surface of a 50 mm diameter bar, each carrying 1000 amps of current? Twice. 1/2. 1/4. 4 times. Question 67. What is the magnetic field strength at the surface of a 25 mm diameter bar as compared to that at the surface of a 50 mm diameter bar, each carrying 1000 amps of current? Twice. 1/2. 1/4. 4 times. Please check all your answers. Thank you for watching. Keep supporting.